I have the sound muted, I guess. Okay, so...
Is your mic muted too? Or?
No, it's good. That's good. Oh, so I even told you where to write code, right?
Yeah.
What the heck? Okay. So we already have it. We need these guys to go into request mode. Oh, and didn't I even say you have to do 2 threads? That's the bad way we're going to do it? Yeah, 2 threads. So where's Tim?
Where's half of them? Where's Abe?
Well, Abe texted me saying he's going to be a few minutes late.
Yeah.
There was a bathroom incident.
Did you send it?
It's 5 minutes now.
Oh, actually, he said they took forever at DQ getting my food. So there's a future bathroom incident.
Okay.
He was eating food from DQ. So, in any case, Tim, who is our original client, who's not here, which is a problem, he's going to establish a connection, set it up. He doesn't need to have the secondary thread, the thread for asking for stuff. And I think we wrote both threads last time. Isn't that right?
Mm-hmm.
Yeah.
By request thread and
So didn't I like do everything?
Well,
aside from finish it.
Here's the byte request thread. Here's the file fill thread. Okay. Okay, so byte request thread, this guy is going to constantly go through. Oh, look, I even wrote it. This guy constantly listens for a request. Why couldn't you do this homework?
just keep going. Just keep going.
Does something bad happen?
Just keep going.
Something bad happens?
Just keep going.
All right. So this guy constantly listens for a request from the server for a certain byte and responds with the byte. So we have our byte array, because don't we have a client helper thread? This guy? He's abstract, right? So this guy keeps track of the file array. And what this dude's going to do is our byte request thing is he's going to go through that array over and over and over again and request. Anytime he sees a -1, he's going to request the byte, right? That byte bucket, byte bucket. So he has this array called the file array. So let's go this route. Byte request thread. This is, oh no, this is the file fill thread. Yeah, this is the one where he constantly tries to fill up his own array. Okay, so what we need to do here is we're going to continually spin through our array. So here's the loop that goes through our array. So for int I is equal to 0, I is less than this dot file array dot length I plus plus if this dot the file array at bucket I is equal to -1, request this byte. That's what we want to do in there, right? Okay, and we want to keep doing this over and over and over again until we get all of the bytes. Until we get all the bytes. Okay, well, what does that mean? That means we probably need to loop this multiple times. So I'm actually just, for right now, I'm going to throw this, we're doing this ghetto anyways. I'll throw this inside of a loop. So after we come out of this, we'll have a count starts off at 0. We'll keep going inside of this this loop. We'll go through every single bucket of our array, requesting a byte. Now there's no guarantee at this point that we will receive the byte. We might get a bad response from the server. So if we ask for byte 4 and we send the request out to Jake for byte 4 and he can't find anybody to fulfill that, he's going to let us know. And then we need to say, okay, we'll move on to the next byte. We didn't actually get that byte. So that's going to happen in here. So request this byte. May not get the byte and should move on. We put that little comment in there. All right, so after we go through this entire for loop, we need to ask the question, if count is equal to this dot the file array dot length then we can break. That'll get us out of the loop. We have all of the bytes
You need to increment count at some point.
Yeah. in here when we actually get it. So request the byte, may not get the byte, so here, we'll request it. Here, just so we don't forget for right now, we'll say count plus plus in here if we get the byte. Okay, so if we're going to request the byte here, we need to send a message to our server, right? The server we're connected to. And let's go back to our, who we got here? This is that's the server code. So we got to go to the client. From the client's perspective, client communication protocol. Okay, here's the share file codes. We locally buffered it. Then we have our byte request thread. Similarly, this guy is going to have his, we have a byte request thread here and a file fill thread. So we tell both of those to start. So whether you're getting a file or you're copying a file, we get the ball rolling from here. Now these guys, they need to have access to the server stuff for communicating with the server.
The socket's on the top.
Okay, so we need to send the socket in to those. Or I guess we can actually, didn't we write an object or is that just on the server side?
That's just on server side.
That's our connected client. That would actually be, that would be handy to write that on our server, on our client side, wouldn't it? Let's create a new thing called connected server.
Dave's fault.
Well, what did you bring me?
He brought you fries and a burger.
I can't have fries, that's carbs. I can have the inside of the burger. Bring it up here.
We all
Hand it
want to
over.
watch this.
This is what we said.
Is it a fish one?
Huh?
Is it not a fish sandwich?
Well, I assume when you say burger, you mean an actual hamburger, not a fish.
Bacon.
With bacon? No.
You ordered it.
All right, shut up! You missed a quiz, by the way.
Told you.
All right, so connected server. So when we connect to our server, we're going to have, this guy is going to have a private socket, the socket, import a couple things. We're going to go ahead and do our connected server. What?
Doesn't like you. Import.
Right, but shouldn't it give me that option? What are you doing? Didn't I have this problem the other day?
Yep.
It's java.net.socket, isn't it? All right. Import java.net.socket. Thank you, Eclipse. All right, so private socket, the socket, we're also going to build out some other things, but let's just start with this. So we're going to say public connected server takes in a socket, this dot, the socket equals the socket. Okay, and then we can go ahead and establish a couple other things. And we're going to do this similarly to our connected client where we need to have the, well, hello, what did I do? I need an
You
old
need to
priest and a young priest.
Drag the connected client up top. No.
Boom.
No, stop. Don't split it up even more.
Oh, drag both of them down to the bottom.
I'm guessing I
Or
can.
just delete.
I'm guessing I can just close everything and reopen it.
You can just close the top one. Just stop. Close the top one.
Now it's a tie. Ay, ay, ay.
Like all the things that-
All right. So in any case, so we have our connected server. We're going to do similar stuff to what we did here in our connected client. This guy over here. All right. So connected client sets up some print writers and things like that. We need to actually also have the ability to send in some bytes and stuff. Okay. So we're going to have our. I'm going to go ahead and just steal a couple of these things. So we're going to have a print writer output and a scanner input for reading text things. Okay. So we'll steal those two things and put them in here. Similarly, actually, we'll go ahead and just set those two up right here. Exact same way. See, here's the advantage of naming my variables consistently. I don't even have to change the name of my variable. You've made fun of me for calling it the socket and the this and the that. I'm gonna actually make something called the this and the that.
You talking to me?
Everybody.
No, I'm not talking to you. Variable names.
Well, if it's fine, as long as you're consistent across all your classes. All right, so connected server, we're going to set up these couple things. This is for textual type of writing of crap. So this is our send message, and this is our get message, right? And then we'll have to add in the read bytes. Actually, you know, we can almost steal, we'll steal most of this. So a read byte as well. All right, so now we have the ability for the connected server to send a text message, to receive a text message. Carrier rates may apply. And then also read a single byte. And we probably should also be able to send a byte, correct? We'll add that here. So that's not over here on this side, right? Added byte, blah, 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 blah. Nope, perfect, done. Okay. So to read a byte, we're going to read something in and just spill out the end. What we're going to do over here on our, so kind of connecting this back now. Let's go back over here to, we're on the client side. Client communication protocol. We have our server. Man, look at all this extra crap we have in here. Need that. We have server output. We have terminal output. We have, all right, I'm not actually going to break that. So I'm just going to create another private variable up here. Private connected server, and we'll call this guy CS.
Season for me was yesterday for the second season.
This guy will be this dot CS is equal to a new connected server this dot the server. Okay, and as long as we're consistently lazy with exceptions, we don't have to deal with that. All right, good. So now we have our connected server. So down here, where we're sharing a file, and keep in mind we could use our connected server to do all this stuff, all this communication we already have, but since it's working, I'm not going to change it. Okay, so now when we create our byte request threads, we need to also pass in, well, byte request and the fill threads, we need to pass in our connected server. So in our file fill and byte requests, we need to provide it with the ability to talk to the server. We do that at the client helper thread level. Protected, connected, server, CS. This guy will take in an array as well as a connected server CS. We'll say this dot CS is equal to CS. All right, and this is our abstract class. So at the top level, anything that inherits from client helper thread will have access to the file array as well as the connected server for our communication with between the client and the server. Okay, and then down here for fill thread and byte request thread, we need to add some extra stuff here. So let me actually just steal the second part of this. So the constructor for these guys needs that second parameter now. And then we need to pass that second parameter into our parent's constructor. Similarly, file fill thread, second parameter, pass the second parameter to our parent's constructor. Okay, so now we can get rid of the client helper thread. All right, so now we are back to where we were before, where we're just constantly running through our file array, looking for places where we still have a -1, knowing we have to request that byte. And now we need to ask the server for a byte. Okay, so this is all on the client side. So what we'll do is we'll say cs.sendMessage, and we're going to say byte concatenated with I. That's a request for a byte. So actually, yeah, byte colon. So I'll say byte colon 5, and that's a request for the 5th byte from the array. Make sense? So we'll send that message, and then we're going to wait for a reply. So we'll read a byte, but where does reading byte come from?
Is get messages in it.
Read byte. Does socket get input stream? Oh, perfect. No, not get message. We want a byte. When we ask for a byte, we're going to expect a byte back.
Okay.
So that's what I want to read in next. So here I asked for a byte. So give me byte 4. Then I'm going to try to read in int the byte is equal to cs.readByte. And was this guy throw an exception too? Hey, can't do that in a try catch, because, or I have to do it in a try catch because this guy will break. So we'll go in here, and we're just gonna do all this inside of a. That's actually even too bad at programming for even me to do. We'll do everything in here in a try catch. That's reasonable enough. All right, so we'll send the message. This is our request. Byte 4, for example. We're only inside of this if the current element of our file array has a -1 in it, which is what we initialized our array to. Okay, so if we see a -1, we'll ask the server for that byte. Then we'll read the response from the server. If the byte is not equal to -1, so we're making the assumption right now that the server is going to send back a -1 in the event that it can't fulfill the request. Okay, so server sends back a -1 if it can't fulfill the request. So if it's not a -1, then we're going to say this dot the file array at bucket I is equal to the byte. So fill it in, and then we'll say count plus plus. Okay. So this is on our client side. So every single time through, we'll identify a byte we need. We'll ask the server for that byte, wait for the response. Server sends the response back. That response is either going to be the actual byte or a -1. Okay? It'll be the actual byte if the server hands it off to a real client. It'll be a -1 if the server just default replies and says, I don't have anybody who has that byte. Try again. Okay? So now we got to go write the server side of this communication.
it's going to be a -1, do you even have to ask if it's not a -1? Because wouldn't you just set another -1 to -1?
Yes, but you don't want to increase your count. So you're going to have to ask that extra question anyways. You don't want to set it, you don't want to overwrite a -1 with a -1 if your way to break out of this infinite loop is when your count is equal to the length of the array.
Okay. Oh, okay.
That makes
I see.
sense?
Yeah, I see.
I don't want to accidentally count a -1 as being a found byte. Okay, so now we need to, so this is in the client communication protocol, we need to pass in CS to all of our threads when we create them. There's CS there. There's CS here. CS there. You know, this is actually getting substantially ghetto. It's kind of fun. Okay, so that's on the client side right now for the file fill thread. So we need to go over to the server side. And this is our response thread dealing with the server. Okay, so if we're in sharing mode, then we don't need to worry about requests, correct? Well, we don't need to worry about accepting requests for bytes if we're in share mode. That means the connected client to our server was Tim, who is not requesting bytes. So we're only requesting bytes if we're over here in the getting mode side of things. Okay, so here's the wait for client to request a byte. Oh, look, we even already wrote this. Which byte? All right, so we need to go ahead and split this into parts. So string array the parts is equal to which byte dot split on the colon. And we know that bucket 0 will be the word byte, and bucket 1 will be the, you know, actually, having said that, do we even need to, why are we even putting the word byte in front of it? I don't think we need to. We'll just do it since we already wrote it. Never know, we might add to our protocol and have other requests coming in through something centralized, so having the byte in there is fine. So the parts at bucket 1 will be the actual byte we're interested in. So we'll say int the byte is equal to the parts at bucket 1, and this is integer dot parseInt of that. Okay, so that's the byte. That's the guy that we need. So now we're going to go through all of our connected clients that are not busy, and we're going to say if it's not us, and we even wrote that part of the code. We wrote like large chunks of this. All right, hold on. I'm getting rid of all this crap. We're just going to stick with which byte, which means I need to go back here to the fill file thing, and this is no longer this. Now it's this. I'm just sending a byte number. CSN message, empty string concatenated with I, the byte that I need. That comes over here to our client communication protocol. Nope, comes over here to our response thread. We receive the byte we want right here. Go through our list of non-busy clients. If the client is not us and they have the byte that we're interested in, integer.parseInt which byte, then we're going to share the byte with the guy that just connected. Okay. Write code here. So this guy requested it. This is the client. So we're going to say this dot the client dot. Do we write a write byte?
No.
Okay. So that's a connected client. Let's close this. Open this. Okay, so we're going to say we need to send a message. Public void send byte. This would be this dot the socket dot get output stream dot write. This guy's going to take in an int the byte, and we're going to write the byte. And this guy throws an exception. Perfect. Throws exception. All right, so now we've added the ability to write a byte to our connected from our connected client. I'm going to go ahead and just steal this because we're going to have to allow our individual clients to also write bytes. So we need to do this on our connected server as well. So there's our send byte. Okay, so we're in our response thread. So we'll say this dot the client dot. What is the client? Client dot. Can I just write it? Oh, I called it send byte. Oh, the name of the function's right. So send byte. The byte we're going to send is what? We need to read a byte from a client that's willing to share a byte. Okay? We've identified a client. Which client? CC. So we need to say CC dot, we can say read byte here, but actually read byte's going to, we probably need to set him up to say, please send me this byte. So this is coming from Jake. He needs to tell CC, who's currently busy, who currently has the byte, that we need to actually get the byte from him. So this is, we're following the connection here. So this is in the byte request thread. So each client connected, this is on the client side, is going to constantly be waiting for the server to request a byte from them. Okay? So right here we're going to get a byte. So we're going to say string which byte. And this is going to be equal to cs dot get message. Okay, so we'll read in the message for the byte that we are expected to fulfill. Now, we shouldn't have to check to see if we have it. We shouldn't be asked unless we do have it. Okay, so we're just going to assume perfection and not do any error checking. It's always done well by me. I've actually never had a compiler. Except this one. Hold on. All right. So we need to set. I'm not sending a byte. Hold on. I'm sending a message. Oh wait, no. Yes, here. Everybody relax. And you say cc dot send message. The message I'm going to send is the empty string followed by which byte? Actually, I don't need to do the empty string. Your guy's already a string. Just which byte. So I'll tell the dude who I just determined has the byte that I need. I'll send him a message with the byte. He will then read in that message right here. So now he knows which byte. And then what he's going to do is he's going to say cs dot send byte. The byte he's going to send is integer. This dot relax. This dot the file array integer dot parse int which byte. Okay, so that's that. And this guy has a try catch. That's fine. Try to do this crap. Catch a problem. Do nothing. Okay, so This is our byte request thread, and this guy just sits here in perpetuity until you kill off the client, just like if you close your BitTorrent client at home, it no longer shares crap, right? But there's some more convenient ways. You could just hit the little X after you finish downloading the things, that'll remove it off the queue. You're no longer willing to share it. But this guy's going to sit here, read in a request for something he wants. Then he's going to send that byte back to the server by reading the byte from his file array. When he sends it back to the server will then receive it. That's CC read byte, and we need to we'll just do all this inside of a try catch. Okay, so we'll say which byte we want. We already know he has it. We wouldn't be inside of this if statement if he didn't have it. So we'll request it. We will receive it right here and send it right on to our client. Okay. Now, what happens if we go through this entire array of not busy clients and we don't find somebody who has it? We need to write a -1 back to the guy who requested it. Okay? So I need to have a little Boolean here. I'm in the response thread. Oh, this needs to be in a infinite loop, right? For right now. So this is while true. So this response thread is the communication channel between Jake and the connected client. And he's going to keep having that client request the byte and then go and find the byte for him or try to find the byte for him. Okay, so we'll say while true there. Okay, my good rule of thumb is if you're ever going to have an infinite loop in your code, have 5 infinite loops in your code. No more, no less. Minimum of 5. All right, so inside of here, I'm going to say Boolean.
I think you might want to reword it. Unless that's what you're going for. No more, no more.
Was
no
there
more,
phrasing?
No less, minimum of 5.
No more, no less, minimum of 5. So not phrasing, just wrong?
Yeah.
I'm okay with that. I think I got through half of a statement and then started a new statement.
That could be it.
Pretty sure. What was I doing? Oh.
Making no more, no less.
No more, no less,
5.
infinite loops, KK, thanks. All right, so we have a Boolean found byte, and this guy is going to start off as false. Okay, if we did find the byte and we sent the byte, we'll go ahead and say found byte equal to true. All right, if not, after we get out of this for each loop here, we can ask the question, if found byte, well, we could say if not found byte, if we were not able to fulfill this byte for the client, the one he requested, then we're going to write back to the client this dot the client dot send byte -1. I guess I got to put that in a try catch.
You need a variable.
Oh, thank you. All right. So if not found byte, try to send the byte to the client. We're going to send him a -1. That means when the client then receives that, this is on our file fill thread, he receives the byte right here. If the byte was not equal to -1, he'll go ahead and mark it as found. Okay. Otherwise, he just continues on and moves on to the next byte. Okay, so this guy here is just going to walk through his array one byte at a time. Anytime he finds a -1, he's going to ask the server for the byte. Then he'll read the response back from the server. Well, so here, this is the actual step. He asks the server for the byte. The server then receives his request right here. Then goes through the process of looking at his not busy clients for the byte. You almost have to make a wonder why we even had not busy clients in this the way we're actually doing it this way. Well, whatever. Okay, so his not busy clients, ask them for the byte. If you find somebody who has the byte, he sends the byte and then sets found byte to true. Otherwise, if found byte was false, he's going to send a -1. In either case, we receive a byte, either a -1 or a real byte. Okay. If the byte was not a -1, that means it was a real byte. So we'll go ahead and fill up our file array at bucket I, the byte we were looking for, with the byte we got back and increment our count. We found another byte, received another byte. Make sense?
Are we going to do anything with the not busy clients?
Possibly.
Because at the moment, I don't think you're changing.
Yeah, we might. We'll have to see how this byte request thing is going to work. Okay, so I think that the file fill request should be functioning now. Okay, on the response thread side of things. And I think where we are going to need it is right now our response thread only accepts, well actually, a response thread only accepts connected guys, blah, blah, blah. I don't think we actually need to change it. I was going to say we can spawn off as 2 threads on the server side, but I don't think we have to. I mean, we're doing communication right here, all within a single thread. And this shouldn't block. We have access to this guy. There's a possibility we're going to have to thread this, but I don't think we will. Because we have a pointer that leads to this client, and that client is running currently within a thread, which is a separate thread than the current thread we're running in within this response thread. So we have 2 separate response threads. Okay, we have 2 separate response threads. One of them dealing with us, that is the client. Okay, we are the client in here. The other one is dealing with the other guy, that is CC. CC. Okay, so each of those guys is living in his own response thread. Okay, therefore, he's not blocking. So this response thread can talk to CC's response thread and ask him for a byte. That should work. I don't think we need to create a second thread for CC to be able to handle this.
What if you have 2 response threads that try and contact CC at the same time?
It'll be a race condition, so I think they should be handled. Actually, it won't be a race condition. I think threads in Java are thread safe. Therefore, if 2 guys request from the same thread at the same time, they'll just be handled in order. I think one of them gets blocked. It'll be a semaphore inter-process communication thing that'll block it. So I think this should work. Okay. So then inside byte request, we're already handling that. So forever, we receive a byte, send a byte, receive a byte, send a byte, or receive a request, send the byte. And then the file fill, we just do this. Eventually, we break out. And our entire array is now filled up with bytes. Now we have all the bytes, so write it to disk. All right, do we still have that code somewhere?
I didn't see that.
That would have been in our original response thread, right? So we can just do this. Go here. Distributed server, original response thread. Let's look at history. Initial commit. Oh, why am I in connected client? I want a response thread. Cool.
Oh wait, no.
Connected client. It's driver. Oh yeah. Okay, that's the server we wrote. And I guess we just might as well just write it ourselves. So we need a file output stream. So do we have the, here we go. Okay, so we have our,
That's filter.
huh?
That's filter output stream.
Oh, good. I was testing you.
Oh, right.
File writer, can we write,
Can we write files with files?
can we write bytes? This guy came from a output stream writer, which should allow us to write bytes. Yes, we can. Okay, good. Perfect. That's the filter writer again. See, I was testing you.
Reader.
That's a reader. That is file writer. I told you I was off. All right, so.
I thought I was having an off day.
Wait, where am I? I'm lost. Let's see. We are in the fill file thread. We have all the bytes. So now what we need to do is we need to go ahead and create our file writer. FW. This guy's going to be a new file writer. We need to give it the name of the file. Do we have the name of the file somewhere in here? Well, given our time, we're going to call this guy bob.jpg.
D2f.jpg.
Okay, we need to import java.io. What's up with this?
It hates you. Does the shortcut work?
It would. There, I have entire IO library now.
What's wrong with try catch?
Throw try here. Man, 3 minutes. We got this. We got this. Catch, exception, E, do nothing. What's that? So file writer bob.jpg. And actually, over here in our we need to tell it the my files directory. File fill. All right. So we're going to store it in my files, Bob JPEG, and then for int I is equal to 0, I is less than this dot, the file array dot length, I plus plus fw dot write this dot the file array at bucket I, and then finally fw dot close. All right, I think that should all work. So after he's done filling it, the file will be local. Let's test it real quick in our final minute. We need to get our server started. We need to compile it first. Driver, then we need to get our share client. Java driver, I'm sharing one locally buffered. Then we need our get client. Oh, I just want to check something. Okay, there's my files. Okay, good. Java driver. Let's just say get ready to receive on Rickroll. So that guy's still sitting there. My guess is he probably already has the file. We'll go ahead and actually start except they're going to keep overwriting each other's bobs. But if we go into my files on the client, do we have Bob there, or does it not update there? Let's just kill it here. Where's Bob? All right, we'll finish it next time. We'll have to do some little output, but this thing should be pretty close to working. We'll have to show that he received a byte, received a byte, received a byte. My guess is that count must be 1 short or something where we aren't ever breaking out of that to write it out. In fact, you know, real quick, I'm actually going to system.out.println writing to disk. Kill that. Kill that. Run this. 1 second. This. Share. This. You're gonna get. Yeah, see, it's never getting to that part. It's never actually getting to the part where it's writing out. Yes.
I will not be in class on Wednesday.
Okay.
I have a doctor's appointment.
That's fine. Just watch the video.
Okay. Also, student government is putting on a lecture series for teachers,
Okay.
and you can talk about whatever you'd like to. But I was
Okay.
wondering if you wanted to be a part of that.
I'd be interested in finding out more. So tell me.
Yeah. It's going to be in the next couple of weeks, just before school ends. We're trying to do 2 at night, whatever time works for you, whatever day works for you.
Okay.
So you can talk about computer stuff for food or whatever,
Okay.
whatever triggers your trigger.
Okay.
So if you want to send an email or let me know.
Okay.
maybe
Well,
tomorrow or
yeah.
something.
Shoot me an email so I can
Okay.
reply to it. We'll go
Right.
from there.
Okay.
Sound
sounds
good?
Thank you.
Yep.
Well, next time you go fishing, tell me.
I'm going right now.
Well, I got work, but
You just told me to tell you next time I go fishing.
well, next time, because I'm free all this week. I want to see if there's any good metal detecting spots around your fishing area.
What?
Good metal detect. You just started doing metal detecting now, so you got magic tricks in metal detecting.
Yep. It's relaxing being out in nature, just finding crap.